Okay, we're going to do a few problems on page 216. The problems that we're going to be doing are basically proofs. And so you've got this blank canvas, you've got some givens, you're trying to prove certain things to be equal. Within this section, you will always notice that what you're trying to do is prove that these two triangles, the one on the left and the one on the right, are congruent. And that would be the last step of our two-column proof here. And when you are trying to prove triangles to be congruent, before we even start, you're just thinking about it. Well, here's the two triangles. You've got to ask yourself, well, what are the different ways? Well, there's side, 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 angle, side, angle, side, angle, and angle, angle, side. So somewhere along the way, you've got to prove three parts of the triangles match up, whether they're sides, whether they're angles. Okay. That is your goal, and then once you have any of these type of combinations, then you can say the proof the two triangles are equal because of one of these four scenarios. So now we go back to where we're starting. Given angle V is equal to angle Y. Now I like to draw the pictures because I can mark up the pictures. Angle V is equal to angle Y. So we already have an angle done. Okay. This of course is given. And then also in the given it says WV bisects angle VWY. So let's follow those three letters here. VWY here in pink. V to W to Y. Okay, so this line WV bisects this pink angle VWY. So why did they state that? Because that's not saying sides are equal. It's not really saying angles are equal. But this statement does split two congruent angles. Because this WV is the bisector, that means this angle near the top here is equal to this angle near the top. And so let's label these angles here. This is VWZ on the left is equal to YWZ. And the reason why is because you just mentioned a bisector. And so we're going to go DEF, definition of an angle bisector. If you want to spell it out, WV bisects the angle, therefore the two angles are equal. Alright, now again, step 2, I got another angle there in red. You don't have to write that, but I like to show that I've got two angles. So I need another side. Angle, angle, angle is no good, so don't bother with the third angle. We need one side to be congruent. So is it, if I look at the two triangles, is it the pink equal to the pink? Well, maybe. Is it this bottom equal to this bottom? Well, maybe. But there's no indication that whether in the given or is this the midpoint. Never said that. But this third side length is being used by both triangles. And that's the third step is going to be WZ is equal to WZ. And that is because of reflexive property. And now we have the side. Now if I take away the two pictures here, here's the picture on the left. I got a tick mark here, I got a tick mark here, and then a side length. Here's the triangle on the right. Got a tick mark there, a double tick mark at the top, and then a tick mark there. So now I can say that the two triangles are equal, and this will be the proof, what you were always trying to do. VWZ is equal to triangle YWZ, the left triangle and the right triangle are congruent because of there's an angle, not the side, another angle, and then the side. Angle, angle, side. I don't put the S in the middle. There's an angle, no side, but there's another angle, then a side. Angle, angle, side. All right, here's number 20. Again, we're trying to prove two triangles are congruent, but let's pay attention to the triangles involved, because if you look at this picture, there's actually 5 different triangles. There's this one here near the top, one at the bottom, there's a bigger one here to the left, bigger one here to the right, and then there's this triangle here. So it's critical that we recognize which triangles we're looking at here. So MON, so that's the pink one, and QOP, this yellow one. Why is the pink triangle equal to the yellow triangle? This line here is almost there to throw you off. Okay, this is actually going to make life more difficult. You can almost look at this as, why is this triangle, this is what we're going to try to figure out, why is this triangle equal to this triangle down here? And if I take away this one line connection, it actually is a little bit easier to figure out. All right, let's go right to the given and see what they give us. Angle N is equal to angle P. That's an angle. Given. Angle MO is equal to QO right here. So now I've got an angle and a side. I need one more piece that might be equal. Can I say this side is equal to this side? Well, there's no indication of that. Can I say this angle by Q is equal to this angle by M? Well, no, there's nothing really there. But this dot is equal to this dot, which is this dot here and this dot here. And we are going to say angle in pink, M-O-N, angle M-O-N, where the top dot is equal to angle Q-O-P. Now the question is why? Well, what type of angles are these? These are vertical angles, and vertical angles are congruent. So you've got to remember some stuff from the past. Vertical angle theorem, or we can just say vertical angles are congruent. When you've got crisscrossing lines, these two dots will be equal. Whoops. Okay, so that gives us another angle. So I'll tick mark that and tick mark that, and I should have enough to say that the two triangles are congruent. So that's step 3. Pink triangle MON is congruent to yellow triangle QOP. Let's look at the picture now. Don't just say side, 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 or side angle, side. Let's look at the picture. Where are the tick marks? There's a tick mark, tick mark, tick mark. Angle, angle, side. Angle, angle, side. So this again is angle, angle, side. Don't put the S in the middle. If there was a tick mark here between the two congruent angles, then it would be angle, side, angle. But that's not what this is showing. That is number 20. And finally, we'll go over this last proof here, number 22. We're going to, again, prove two triangles are congruent. So you've got to get 3 parts to be matching up, whether they're angles and sides. We'll figure this out. Let's look at the starting line. AE is parallel to BD. Okay, so I put little parallel tick marks. Now, that does not mean those sides are equal. Oh, but here it is. The very next line says AE is equal to BD. So now we've got S for side. And of course, this is all given. And there's one more thing in the given. It says angle E, way here at this tip, tick mark, is equal to angle D, tick mark. And of course, that's an angle. So I've got a side and an angle. I need another side maybe, or another angle maybe. So you've got to think about, well, what could be the same? You know, maybe AB is equal to BC, but nobody told me this is in the middle. If they said point B is the midpoint, then I would know left is equal to right. What they did mention for some reason in the given, we got 2 parallel lines. And when you have parallel lines, a lot of angles could be equal. And in fact, this dot angle is equal to this dot angle. So let's write down this angle where the dots are. Angle EAB is equal to angle DBC. Now we need a good reason. Let's look at these parallel lines again. Here's a transversal. I'm extending the transversal. Here's those 2 dots. Those are equal because those are corresponding lines. So, I mean corresponding angles, excuse me. So corresponding angles in parallel lines are congruent. Corresponding lines postulate. Okay? Again, this picture might not look like it, but if you extend these lines a little bit and extend this transversal, you will notice, oh, top right corner, top right corner, top right corner, top right corner. Those are in the same corresponding positions. Now, that gives me another angle, and now I should be able to say that the 2 triangles are equal. So right with the proof, triangle AEB is equal to triangle BDC, and it's going to be side, 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 angle, side. One of the guys here, this is going to be an angle, a side, an angle, angle, a side, an angle, angle, side, angle.